Agile and Extreme Programming with Bob Martin.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. Make sure to check out www.azuredevops.show for past episodes and show notes. And I'm excited that lots of people are taking me up on my open invitation to speak at your virtual user group meeting. And I'm pretty much getting something every other week or every third week on my schedule. So many .NET user groups around the country that are doing video presentations and video meetings. So it's a lot of fun. And if you run a .NET user group, I'd love to get on your schedule. Also, if you're tuning in to the show for the first time, this podcast is for developers who are shipping software with Microsoft technologies. And my goal for all development teams is for them to be able to move fast, deliver quality, and run their systems with confidence. And if you have some specific issues you'd like help with, my company is a software architecture company, and our focus is on empowering Microsoft-focused development teams. So give us a call. And now let's get on to the guest. Well, today I have with me a really exciting guest. Robert C. Martin, better known as Uncle Bob Martin, is here with me today. And he's the author of a number of clean code related books, including the latest Clean Agile, as well as 5 others. And he's also the promoter of the well-known solid principles and an original signatory on the Agile Manifesto. Bob, how are you, sir? Welcome to the show.
I am very well, Jeffrey. Thank you.
Awesome. Well, I appreciate you coming on the show. And there's so many people who are familiar with your work, and you've been doing this for a long time. But our industry has grown so much for the people just getting into this field and maybe not as familiar with these. What do you think is what are you the proudest of out of all the things that you've been involved in? Just for people to get to know you a little bit.
Oh, that's an interesting question. The proudest, huh? It's probably the Agile movement. I think that's had the most profound impact on software over the last 40 to 50 years. It was a very good thing to be involved with that. I think we did good. I am not at all pleased with the direction that Agile has been going lately, which of course is why I wrote the Clean Agile book. But in general, I think that that movement did a lot of good for the software industry and for software developers across the world.
Yeah. And for people, I think according to the stats, 50% of the developers now today got into this field in 2013 or later. So they don't even remember, the event and the events leading up to the Agile Manifesto. But people used to spend months and months on design and then spend months and months on laying out code, and it was really long projects.
The idea of waterfall is actually fading into the dark past.
Yeah, that's good.
There are still people out there that do it, but far fewer than used to. And most folks nowadays recognize that that's not the right approach for an industry like ours.
Now, Clean Agile's your latest book. What did lead you to think, you know what, I need another book, and this is the one it needs to be?
Well, so what happens in our industry, and it's happened many, many times in the past, is that a good idea comes up, and there's a lot of fanfare and a lot of enthusiasm, and then the marketing people get involved, and they begin to invent new attributes and new things to put in front of it, and you start developing adjectives. Adjectives that can go in front of the old idea. So now we have, large Agile or scaled Agile or new Agile or whatever it is. There's always going to be some new adjective because the marketing people need to differentiate, which is perfectly fair. Unfortunately, what then happens is that they have to differentiate not just by name, but also by substance. And some ideas get into the substance of the idea that never should have gotten there in the first place. So I wrote the book as a way to combat the leakage of bad ideas into the original idea, which I still think is profoundly good.
I remember Kent Beck's Extreme Programming book, and then XP juxtaposed to Scrum, and then Kanban, and now DevOps. If we were to kind of not care about the history and just say, today, I'm building a team today, and I got to pick a methodology, or I got to pick some practices, which would be on your short list?
Oh, it would be as close to extreme programming as I could get it. I think when Kent did that, he wrote that down, these points. I think he nailed what Agile was really about. And in fact, before he did that extreme programming stuff, nobody even thought about trying to gather everybody together and come up with a unified idea. But it was when Kent did that, and he wrote the extreme programming book, and he published lots of articles, and of course it was at just the right time. It was right when the .com bubble was just about to burst, and it was at its height. And the rest of us thought, you know what? There's a lot of folks who have had good ideas. Kent's got the loudest voice here, but there's the Scrum guys, there's the FDD guys, there's the DSDM guys, there's the Prags. We got to get them all together and hash out what this all means for software in general. And that's what the Agile movement was. Now, if it's me, I'm thinking, okay, I believe that all of the other Agile-like processes are subsets of extreme programming to one extent or another. And that extreme programming was the best defined, best laid out, best articulated of all of them. It is not the most popular in today's world. Something else took over. Well,
extreme programming has some elements that are not even talked about these days. And I'm thinking about, was it metaphor? And so, I mean, just if we really get down to, okay, well, extreme programming, I've never heard about that. Let me go and research it. And then I really start looking at it. When you say, hey, get close to XP, what concrete practices are you really thinking about here in 2020?
So you start with the Scrum practices. So Scrum is the outside edge of extreme programming, and it's very faithful to that. So if you were to look at extreme programming and look at Scrum, you could easily say, oh yeah, Scrum and XP, they're roughly the same as far as the way they talk to the customer, as far as the way they plan things and estimate things. There's minor differences, but who cares about that? The general philosophy is exactly the same. But what Scrum does not have are the engineering practices. And extreme programming was really focused on these engineering practices, things like test-driven development, refactoring, simple design, pair programming, continuous delivery. All of those things were nestled in the heart of extreme programming and enabled the rest of the practices, whereas Scrum did not adopt that internal engineering kind of focus. Now, many people in the Scrum world have tried to bring that in. That's good, I think. Other people in the Scrum world have completely ignored it, and that leads to what Martin Fowler called flaccid Scrum, Scrum that eventually limps away and fails. Mm-hmm. But again, this just gets back to this point that I think extreme programming got about as close as you can get to the heart of this idea that's Agile. And so the Clean Agile book is really just a reprise of extreme programming with some ideas of what we've learned since.
Okay. Do you know of anyone doing that well, even when, I guess today, every individual programmer would be physically distanced? We're doing everything remote. So the concept of, okay, on-site customer, everybody in a room, right now is, okay, what's the doing your best standard? What do you see there?
Well, so I mean, this is the COVID world, okay, and so we're all distancing and we're all zooming, and the issue, first of all, it's problematic. It is better to be in the same room. It just is. If we could all sit around a table, we could look at each other in the eye, we could smell each other's fear, we could examine each other's body language, we would have a much higher bandwidth communication. And there's no way to get around that. However, this is the COVID world. And fortunately, we have tools. And these tools are spectacular. Zoom, just the one we're using right now, because we're face-to-face, right, is a spectacular tool. And you can get 50, 60 people on the screen and you can see them. It's not perfect. It's still remote. There's some problems, but overall, it's a fantastic tool. So in the short term, I think that works very well, but I would not want it to continue. I would want to have people, as much as feasible, together around a table in the same room, able to hear the accidental overhearing of someone else's problem and all the serendipitous stuff that happens when you get people together in the same area. I would want that to return. So I hope sometime in the next N months, and I hope it's not N years, we are able to return to an in-person teams. Now, that doesn't mean you can't have people, who are working remotely, because like I said, this Zoom stuff does work pretty well. And there are better tools for pair programming. There's good tools that you can get so that you can share screens and do real pair programming, even though you're remote. But nothing beats being together, just in the end.
Yeah. And I personally fought against some people coming into the Zoom, even customers not turning on video. It's almost like, okay, we got to figure out if we were to be in the same building, it's kind of like, nope, I'm not coming around the door. Let's just talk through the doorway.
Well, there's sometimes reasons why people don't turn their video on.
Right. If I was late waking up and I don't really, okay.
Yeah. So
with all of these technical practices, and a lot of them go all the way back. Continuous integration is one of them that's on the list, on the official extreme programming practices list.
Yes.
Do you find some people saying, we have continuous integration, but now we're working on continuous delivery? And what they mean is, I have a computer triggered compile. So could you go over, okay, when Kent Beck said, maybe I need to get him on the show to answer this, but continuous integration, what is that practice? Because I do see some people just triggering a compilation from their Git repository and then saying, we now have continuous integration.
So continuous integration, as it was originally articulated in extreme programming, was the practice of checking code in to the repository on a minute by minute basis, maybe once every 10 minutes. Generally, once ever you got a couple of tests to pass, you would just check in. And if there was a merge to do, you would do that merge instantaneously. So there was this constant integration effort going on. And each little integration you were doing was so small that if there was a merge, it was trivial, right? The goal there was to prevent the guy who checks the modules out, holds them out for a month, and then checks them in, and he's got a 5-day merge to do, right? So that was the original idea behind continuous integration. This was before we had Git.
Right.
We're talking 1999 here, and the best we had was kind of Subversion, which, nowadays to think of Subversion as the best we had is kind of lame. But nowadays, we have tools that are just so good. And to do a merge with Git is as long as you do it relatively rapidly, it's trivial. And so a good team now can just committing in rapid fire and merging as fast as they can. And it opens up this idea of the continuous build and continuous delivery, which I mean, that's a whole different ballgame. We weren't even talking about that in the XP days.
Are you a fan of feature branches or everybody on master?
So when I did Subversion, I was a feature branch guy. You know? Okay, we're all going to have to just do features, and then we'll integrate them later. As soon as I switched to Git, I became a mainline Nazi. I just said, okay, everybody stays on the main line no matter what. We're going to integrate all the time. And that's the way I like to do it now.
Many thanks to our podcast sponsor, Clear Measure. Clear Measure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, Clear Measure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. Clear Measure, empowering software delivery.
Now, your book, Clean Architecture, kind of shows example of a library and the architecture of it, and say, look at the shape, or look at the plans, look at the design. You can tell this is a library, and look, this is a church. Why can't we look at the directory structure and automatically tell what this piece of software is? And how does someone arrive at that reality where you can structure the code base and be able to glance at the directory structure and know what the software is and what it does? What practical guidance, what direction can people go in to go towards that?
Well, so for me, I started programming 54 years ago. And the very first job I had, the kinds of programs we were writing were 200 and 300 lines long. So you could look at a program and know what it did. There wasn't any doubt. You just read the code, or maybe the title of the program was enough. And of course, in those days, it was on a deck of cards. So the name would be scrawled on magic marker on the edge of the cards, and you could read it. And then slowly, over the decades, programs grew. They went from a few hundred lines to a few thousand, a few tens of thousands, to a few hundreds of thousands, and now we're well into the hundreds of millions in even moderate-sized applications. And to know what those applications do, you can't just look at the code. You can't infer what's going on because there's just too much code. So when I started with this idea of just looking at the code and knowing what's going on. And then I noticed that going away, and it wasn't until I saw it was a Rails application that my son had done. And he handed it to me, and he said, "Hey, Dad, would you review this for me?" And he hands me this Rails application, and I look at the directory structure, and what I see there is Rails. Because Rails had a pretty conventional directory structure, and if you could recognize it. And it occurred to me, wait a minute, why am I seeing Rails here? Why aren't I seeing what this program is, what it does? What amount of effort is it going to take me to dig into this just to know what this program does? And I thought, no, that needs to be out at the top level. Somewhere, somehow, in the top level directory structure, you should be able to look at just the names of the directories and say, okay, I get this. And maybe there's one directory called use cases. And if you go into the use cases directory, you see them all there. Okay, all right, I get what's going on here. None of that was in that Rails directory. You couldn't infer anything.
Mm-hmm.
You'd have to really work at it just to get an idea of what this thing actually does.
And so with Java or C#, are there any ways to practically do that with the modern tooling, or any conventions that you found to be useful to attempt to get closer to that?
Oh my goodness, yes. Oh my goodness, yes. These languages we have nowadays are so wonderfully expressive. We've got namespaces and packages and classes and subclasses and interclasses. There are so many ways to organize the source code in an expressive and articulate way. In the early days, we were deeply constrained. If you wrote a COBOL program, for example, there was no way to organize it. The organization of a COBOL program was defined for you, right? There was no way to separate it into useful bits. If you wrote a Fortran program, there was no mechanism that the language gave you to break it up into understandable components. It was just this raw mass of code. And God help you if you were doing assembly language, because then you didn't have anything at all. Nowadays, we've got all these tools. And it is perfectly possible for us to organize our source code into well-named namespaces and well-named classes and well-named functions in a way that makes the code, let's see, it was Grady Booch, I think, who said, clean code reads like well-written prose. And that is possible. A little difficult, but it's possible to do with these modern languages. Do you remember literate programming? Don Knuth wrote those books a long time ago called Literate Programming.
I don't remember. My first programming job was 1997. And so I have read some of the older literature, but not that one.
You're a mere baby, only been programming for 2 decades.
That's right.
So in the 70s, Don Knuth got deeply frustrated with the fact that the languages constrained his mode of expression. And by that, I mean, take a language like Algol or Pascal or C. In those languages, you had a specific order in which you had to declare things. For example, all variables had to be declared at the top of a function. You could not declare a variable anywhere else. It had to be at the top, right? And there was orders imposed upon you. You didn't have the ability to switch the order around. So he came up with this idea called literate programming, in which he would write his code the way he wanted to express it, in the order he wanted to express it. And he would write that in a text file, because in those days we did not have IDEs. And he would put little tags in the text file that would give clues to another program, which he called the Weaver. And the Weaver would take all these little program chunks that were in the order Knuth wanted and reassemble them into the order that the compiler wanted to see them. And that was literate programming. That's how he got his programs to be expressed the way he wanted them to. He actually had to build a tool that resorted
pre-compiler.
We don't have to do that nowadays.
Right.
There's no reason to do that. We can express things in precisely the order and manner that we want to.
Yeah. One of the things that I lament with a lot of the tooling is when you're creating a new project, the tools often ask, and specifically in Visual Studio, they ask, what type of user interface technology would you like to use? That's the first question that we have to answer. The
worst thing to happen to our industry was wizards. These ridiculous little scripts that okay, they're very helpful. If you're going to do a project that is exactly what the wizard wants, very helpful, but you hardly ever do a project which is exactly what the wizard wants. And unfortunately, programmers have forgotten how to build up the project without the wizard. Mm-hmm. So they try to cram everything in the way the wizard wants it to work. And then, of course, they've got to fight against the wizard and fight against the structures that the wizard built for them. This is the constant struggle we have with tooling. Because if you depend on tooling too early, then the tool dominates you.
Yeah.
If you wait too long to depend on tooling, then you're stuck in a manual world, inefficient for too long. So there's this real gentle balance. Any new thing you do, you should do without the tools until you understand what it is the tools do for you And then you can judiciously start to use those tools the way you want to use them, as opposed to the way some programmer in some other country decided you ought to.
Right. That's a good point. I'm thinking of NPM and NuGet, the package managers, and I think every platform now has a package manager where you can get a library or something, just suck it right in, and then we end up with this untenable web of dependencies that we didn't intentionally create, but now it's there.
Right. That the tool, the promise of the tool was to get rid of that unintentional web of dependencies, and of course, what it does is make it worse. It recalls, it makes me remember the promise of DLLs back in the 90s.
DLL Hell.
Promise of DLLs was to be able to organize the binaries so that you wouldn't have this web of dependencies. And then of course we got horrible webs of dependencies. And so .NET came out, and .NET was the answer to DLL Hell. And no, it wasn't.
Right.
we still have DLL Hell. And what that requires is careful understanding of why those dependencies occur and what you can do to organize them properly. And then you can let tools work, but you cannot be dominated by the tools.
Well, speaking of that, and this is a core of your clean architecture book, and you also cite hexagonal architecture, and then also a core tenet shared by the onion architecture way of thinking is keeping your dependencies really, really far away from business logic, from the important code. But the tooling can make that really hard. Can you give your thought process? Because again, our industry has grown so fast that there's so many younger developers been in the industry less than 7 years who are kind of learning all these lessons for the first time, and why it's so important to keep, well, your word, clean code that is free from dependencies. And then how do you even do that? What's your guidance there?
So, I mean, we're faced with programs, computer programs, which have a flow of control, and that flow of control goes from high level to low level. If you start just watching how the program executes, the operating system calls main, then main calls high-level functions, and high-level functions call lower-level functions, lower-level functions call even lower-level functions. And that direction, that flow of control, proceeds from general concepts to detailed concepts. And it must. The flow of control has to go that way. The source code must not. In a clean system, the source code should have dependencies that go in the opposite direction. Now, in the early days of software, we didn't know how to do this. The main program literally called the low-level, the high-level modules. The high-level modules called the mid-level modules and called them by name. It was only with the advent of good object-oriented programming, and this is the real benefit of OO, right? It was only with object-oriented programming that we began to understand at a gut level that we could turn those dependencies around so that I can call a function without having a source code dependency on it. And in fact, the source code dependency is in the derived class pointing back towards me, pointing in the opposite direction. We call this dependency inversion. And what we've learned over the years since then is that a very well-designed architecture is one where at the source code level, high-level policy does not depend on low-level implementation. Rather, low-level things depend on high-level things. So now what's the lowest level thing in your system? Well, it's probably the GUI or the database or something like that, because that's all low-level junk. And all of that code that deals with the GUI or deals with the database or deals with the framework, that's all low-level detail. That should depend on high-level things like your business rules. And your business rules should not depend on anything. They should be kept pure and clean, because that's where all the money's made. That's where all the benefit is in your application. It's in those business rules that, of course, the business has fought for decades and learned for decades, and now they want codified in a program. So you take these really valuable stuff and you put it in modules that do not depend on low-level detail, that are independent of all that low-level detail.
Yeah, and it comes back to tooling. Tooling kind of encourages you to, in the web requests and web pages, hey, here's a method in your web page. Go ahead and put all your code right there.
Yes, well, the guys who make the frameworks will write books, and they will write tooling, and they will write scripts. And they're not thinking about your architecture. They're thinking about their framework. Mm-hmm. So they're not thinking about how you might want to apply someone else's framework. They're just hoping you use their framework.
Right. And
what better way to get someone to use your framework than to get them to depend inextricably upon it?
I think there's this balance between the thought of how to make people get started really quick so that they can adopt it, and then, of course, the long-term robustness. And I'm wondering if that's just an unsolvable problem in the industry with the business model.
I don't know that it's unsolvable, but it certainly is very common. So there's this seductive element to many frameworks where all you have to do is type a simple command and it'll build an application for you. And then you just have to insert a little bit of code here and a certain little bit of code there. And the application just starts to work and it's magic. And that's true. It does happen, right? And if the application you're going to build really is, a 5-feature CRUD system, well, that's probably great.
Yeah.
But nobody ever builds a 5-feature CRUD system.
Right. Right.
Usually we're going to have interesting things in there, and there, complications. And as soon as you put that in, the framework starts to fight you. This is not what the framework's about.
Right.
And especially if you've used the tools to build your application, now you've got a structure in your application that is fighting you every time you want to do something even a little bit interesting.
So, final question here as we end on time, but you've experienced many different waves, not only process, practices, technology. Give us your best prediction. Fast forward us, however far you care to posit. What's likely to happen in your perspective?
What's likely to happen in the software industry? Wow, what an interesting question. So I won't go through all the reasoning with you, but it's pretty well accepted that the number of programmers in the world doubles about every 5 years. And I'm not sure that this 5-year segment will continue that doubling, maybe the next one or the next one, I don't know. But that has to stop. At some point, we're going to run out of people.
Right.
And by the way, this industry of ours has ignored half the population since 1970, right? Because there's hardly any women in this industry, and that's a deep shame. At some point, we're going to have to get that last half. The last doubling will be all women. At that point, we will have saturated the ability of the human race to write code. We can't get any more people to do it. And I have to wonder, how many people that's going to be. Is it possible that 10% of the human population might be writing code 20 years from now? Is that possible? It seems to me it is, because there seems to be no limit to the amount of computers we want surrounding us. On my body right now, I probably have 50 computers. If you think about my iPhone and the iPhone case and the AirPods and the AirPod case and my car keys and my iWatch and all this stuff, I probably have, I don't know, maybe 200 or 300 million lines of code running within inches of my skin. And then if we take a 6-foot diameter boundary around me at the moment, it's an enormous amount of code. And then just expand that. Just keep on expanding. Go in a mile in diameter and think how many computers are in this mile wide ring around me at the moment? How much code is running right now? And that it just keeps on growing and growing and growing. Moore's law died. It died 10 years ago. Computers are not getting faster. Computers are not getting much denser. They're cheap as hell, so we can build them in lots of 10,000s. But at some point, all of this saturates. At some point, our hardware technology will not live up to our dreams. We're going to want to do something that all the computers in the world cannot do, and all the programmers in the world cannot achieve. And I don't think we're that far away from that. So it may very well be that within the next few decades, when we have massive numbers of programmers and massive amounts of computers everywhere, we hit a wall. Now, what might that wall be? Well, I have a prediction. Self-driving cars.
Mm-hmm.
I do not believe we will ever see them. Not the real ones, the utterly automated Uber. I don't think we will ever see, at least not within 50 years. Some really new technology would have to take place in order for us to see that. We will have some cars driving around in extremely well-described neighborhoods during good weather and at a time when the kids aren't out and playing. We will have semi-trucks on the motorways and the highways as long as they don't get off at the exits. But we will probably not have that dream of the Uber that you dial up and a driverless car pulls up into your driveway and you utter the words, "Take me to Walmart." And it drives you to Walmart and it drives you up in front of the door and you get out and it drives away. I don't think we're going to see that.
Okay.
That's my prediction.
Anything that you can see that's unlikely, but you think it's going to be there?
Yeah, I think there'll be a lot more women in software.
Well, that's already happening.
I don't think we'll have any choice about that.
That's already happening.
I hope it's already happening, right?
Well,
I think for whatever the reason was, I don't know exactly why, but that problem has to be solved because we're ignoring half the human race, and that half of the human race has an awful lot to contribute to the industry of software.
Right. All right. Well, Bob, thank you so much for taking the time with me today. Great interview. Loved picking your brain. I appreciate it.
It's my pleasure. Anytime.
Awesome. And for you listeners out there, if you haven't picked up a copy of the new book, Clean Agile, publication date of just at the end of 2019, I believe, go to your latest virtual online bookstore website and purchase your copy. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.